Okay, we are going to use proportional reasoning to solve percent problems. Does that have to be done all of the time? No, but in this particular unit, it's what we want to focus on. So this is our first problem, and what we're going to focus on is setting up part to whole equals part to whole. Now, we know that we always have 100. Let me try that again. We always have one side that is going to be the percent side. So we will make one side be the percent side. This is our percent side, which means that we know that the whole of the percent side is always 100. What we don't know is the part of the other side. So the 45% sticks with the 45 on that side, but in this case, we've got 100 there. So what we're going to show is that, well, we can already see that these two ratios or two fractions should be equivalent, but we're going to use the method that we used before when we did proportion. We're going to cross multiply. So 100 is rewritten with x, and 45 is rewritten with 100. And that is so we can eliminate the variables. No, eliminate the fractions. Now, there is a long way to explain why this works, but at this point, we are just going to focus on the fact that it works. And it has to do with keeping the two sides equal and all those things. But at this point, we don't need to worry about it. So since I've multiplied, I'm going to bring down this side, and I'm going to multiply this side over here. Now, the last step would be to divide by the 100 to both sides, because we want to get that x variable by itself. And it shows that 45% of 100 is obviously 45. So that is explaining that, yes, it does work, because we should have already known that 45% of 100 is 45. If you haven't had time to copy that, please make sure that you do, and we're going to go over to the next one. So it's going to be the same sort of situation. We're going to see the percent side, percent part, and then percent whole equals the part over the whole. Now, again, this is another example where 59 and 100 go together, and we're creating another side that has the part and the whole that's 100. More proof that the cross multiplication technique can work. So I'm putting 100 with x on one side of the variable, or equal sign, and 59 with 100 on the other side of the equal sign. The 100x does not change, but the 59 times 100 turns into 5,900. Our last step is to divide by what is still with our x, and we will be left with x equals 59. Now, again, you should be able to see that these are equivalent fractions because they both happen to be over 100. So it shows that it works. You see, we are still looking for equivalent fractions, but this time we're dealing with percents. My favorite, we're doing it again. There's 100 students in the auditorium, so we have a percent part and a percent whole equals part over whole. Eventually, we can get rid of writing that, but we want to make sure that you know how to do it. So I'm putting my 67 here. It goes with my 100%, and then my students are on the other side. We're still going to cross multiply. 100 goes with x, and 67 goes with 100. Our next step is to multiply, and we're going to bring down that 100x because we can't do anything with it. Our last step is to divide by the 100 so that the variable x is by itself, and we still get 67. So we are still seeing equivalent ratios. This last one I'm going to set up again. with my percents together. So 100 is on the bottom. It goes with 76. There's 100 pages, and we do not know, supposedly, how many pages is 76% of 100. But we're going to continue to show so that we are familiar. 100 goes with X. 76 goes with the 100. We have 100x equals 7,600. And to solve, I have to divide by the 100. I'm using that inverse property. My final answer is x equals 76. I'm yet again going to show that we have equivalent ratios, equivalent fractions. Now, at the bottom, they have finally started doing it so that we identify the part and the whole in each situation. So we need to think about the fact that the total class is our whole. So we're going to put there. We're going to put the part, which is 15 boys. Now this one does not have percents, but if it did, we'll go off to the side and show it. Our 100 goes with I do not know my percent side. So this is my percent side. This is my student side. And we would do 15 over 30. We would solve using multiplication, cross multiplication, and answer. All right, this one is also the same situation. There are 14 pairs of jeans in the store. So that means my total pair of jeans in the store is 14. The part that is in the store is, or that are skinny jeans, are 15, or 5. So what we do not know is our percent sign. We know that there's 100%, and that is the 14 in the whole store. We do not know the percent that the 5 is. So I am going ahead and showing you how to set these problems up so that they could be solved. Okay, there are 15 lollipops in the candy jar. There are 45 pieces of candy in the jar. So in this case, there's 45, that is our total, but 15 are lollipops. We're going to set that up. We have the percent side is still over 100, but we do not know what percent is the lollipops. The 45 is the total number in the jar, and the 15 is the number of lollipops. And you would solve with cross multiplication. So that is the answer to the warm-up and the setting it up. We will do another one in just a minute. Make sure that you have all of this copied so that you can refer back to it.